and welcome to Lessons in Logic number 41. And our background here in the lower right corner is Berry College in winter. That's Berry College in Rome, Georgia, USA. Now, there's one thing I need to clarify. Let me, I seem to have lost it from my notes. Just a moment. And there we go. I wanted to clarify something I got confused about in the last video. I'd had this rule. And then towards the end of the video, or I don't know, 3/4 of the way through, my brain started telling me, no, wait, that rule is called transposition. And I checked something and confirmed, yeah, that rule is called transposition. And I wondered, why did I have contraposition in my notes? Well, I checked, and now I'm pretty sure contraposition was in my notes because that's the name of the rule in The Power of Logic, and maybe some other textbooks too. So, like I said, it doesn't matter what you call the rules, and some of the rules have different names used in different textbooks. You can call it transposition, you can call it contraposition, just don't get confused how to use the rule and be consistent with whatever name you're calling it. It's like a horseshoe versus a tribar. Sorry, a horseshoe versus an arrow, or a tribar versus a double arrow. Doesn't matter which symbol you use, doesn't matter what name you use for the rule. Different systems have us using different symbols, different rules. Just know how to use them properly and everything should be fine. Just define your terms properly and everything should be fine. All right, so now, if I'm not mistaken, contraposition or transposition, if you want to give it a different name, is that rule, P arrow Q, therefore tilde Q, arrow tilde P, or vice versa. Now, a few brief remarks on De Morgan's. Here are three possible uses of De Morgan's. Four possible uses of De Morgan's. You can go from, first, it's not the case that A or B, to it's not the case that A and it's not the case that B, or second, vice versa, or third, from it's not the case that both A and B to either A is not the case or B is not the case, or fourth, vice versa. I like De Morgan's, so there's that observation for you. Try not to get them mixed up. I've seen students mix them up, not always in a terrible way, but it's better to not mix them up, and sometimes it is terrible. That is to say, sometimes it makes you get the wrong answers in your homework and things like that. Now, a De Morgan's equivalence step will do three things. You change an or to an and vice versa. You add or remove parentheses. And if you add parentheses, if I say four things, it does three things. First, change an or to an and, or vice versa. Second, add or remove parentheses. And then third, if you add them, remove two tildes and add one. If you remove parentheses, distribute the tilde across the two statements in the parentheses. If you can just follow the rules for De Morgan's without reading through this or understanding it, fine. It shouldn't matter. Here are some illustrations of how De Morgan's is used. Here are some observations on what De Morgan's does. Let's move on. Let's look at a few more equivalence rules. Now, let me quickly, before we look at the equivalence rules, clarify what we're doing here. First, we're looking at 5 more equivalence rules. Second, we're doing something, just one actual proof for practice. And then third, we're done with this video. And then I think in the next video, we're doing conditional proofs. And then maybe the video after that, we're doing some practice with some very simple practice with the very basics of proofing, because some people still need the simple practice with the basics. And after that, I think we're doing the reductio ad absurdum proofing strategy. And then I think we'll do maybe one quick illustration of proofing with Socrates' argument, because I like it and because it's a good way to practice this. And then I think we'll do a quick overview of statement logic, and then we're finally done with deductive logic, and we'll move on to inductive logic. Yay! So my apologies for any time I said, I think next video we're doing this, and well, we weren't, because my notes had other things I'd forgotten about, or because I realized, oh, we need to go slower and do more stuff first. I'm sorry for every time I say, I think we're doing this in the next video, and then we didn't. But for every time I had the sense to not promise anything, and I said, I think we're doing this in the next video, you're welcome. Okay, anyway, equivalence rules. Distribution lets you do this. I don't know how to explain this or comment on it other than just to say, this is what it does. The statement that P and Q or R is equivalent to the statement P and Q or P and R. The statement P or Q and R is equivalent to the statement P or Q and P or R. So there you go. Exportation, that was the distribution rule. Now exportation. P dot Q horseshoe R is equivalent to P horseshoe Q horseshoe R. Now you can play around with this. You can go from an if A, then open parentheses, if B, then C, close parentheses, to an if B, then open parentheses, if A, then C, close parentheses, by going from here to here, since these equivalence rules can work left or right, and then doing a, I think the word is commutation, switch around the order of the P and the Q there, in this case the A and the B, and then go back in this direction. You could totally do that. It would totally work just fine. But anyway, I digress. That's the exportation rule. The redundancy rule, well, this will occasionally happen. Occasionally, since you're not allowed to skip steps, you can't just conclude that you've gotten to your conclusion without showing that you've gotten to the conclusion. And your premises may give you P or P, P and P. It may give you the statement that tilde T and tilde T, but you just really need tilde T. So follow the redundancy rule to simplify. Material implication, if P then Q is equivalent to tilde P or Q, not P or Q. The material equivalence, and again, the symbols can get confusing if you let them. Tribar and the double arrow here mean pretty much the same thing as far as we're concerned, just as the horseshoe and the arrow. And I've switched to using arrows and double arrows in my notes here instead of horseshoes and tribars. So you're welcome for now using the clearer symbols, but I'm sorry for all confusion. My goodness, here I have both of them, both the tribar and the double arrow. There's no difference that matters in this basic introduction to logic. P if and only if Q means, here's the point, the material equivalence rule. P if and only if Q means if P then Q, and vice versa, if Q then P. Again, P if and only if Q means either both or neither. That's what it means. Let's practice one proof and then be done with this video. So here's a proof I think we can work with. I'm pretty sure I set it up properly this time. I set it up wrongly in an earlier attempt to make this video. Premise 1, if A then B. Premise 2, if either not A or B, then C. Premise 3, if it's not the case that C, then D. Premise 4, if D or E, then H or I. Premise 5, if H, then J. Premise 6, if I, then J, therefore J. Now, how are we going to get to J? Let's try the Beatty strategy. Mike Beatty, Baylor University, work backwards. We're going to get to J from where it appears in the premises. We're going to get to J from premises 5 and 6 here somehow. Now, it probably means we're going to need to affirm H or I, or both. How are we going to do that? Well, we're going to get there from here, I expect, from where H or I appears in premise 4. How do we get that? Well, obviously from where D or E appears. But where does E even come from? I don't know. Actually, I do know, but I'm not telling you yet. But we could certainly do something with D. Maybe that'll get us to D or E. And maybe you already remembered there's a rule for that. How do we get to D? Well, at this point, it's just not helpful to keep adding these arrows. We're going to get to D from tilde tilde C. We're going to get to tilde tilde C from C. We're going to get to that from this. How about this? Where do we get it from? The only place left to look is A horseshoe B. Now, I'm making things a little simple here. I'm giving you a simple proof where you don't have any complexities. You don't reuse any premises. There are a few things here that could confuse a novice, but I don't think there's any real trick questions here, or any premises that get to be reused, or any premises that aren't used at all. I think every step will be used just once. And I say, let's do it. I wish I'd get rid of that blasted, there we go, this little whatever it is symbol. Autocorrect. Stop it, Microsoft. You know what? Let's zoom in and while we're at it. How do we complete this proof? I've set it up so simply, you can actually start with the first premise. My strategy to work backwards, try to figure out where you're going to get J from this stuff, where you're going to get that from here, where you're going to get that from here, etc. allows us to go from premise 1 straight through, probably. It's not always that simple, but I've allowed it to be simple. Don't expect it that way in your homework. I mean, what if I put the premises backwards? Ha! How would that have been? All right, A horseshoe B. That's going to allow us to get directly to tilde A wedge B by means of one step in particular. On line 1, we perform which rule? I believe it's right there. Material implication. If P then Q is equivalent to not P or Q. Now, if you want to think about this and run through with truth tables, you should find this makes sense. If P then Q means that either Q is true or not P is true, one of the two. They mean the same thing. Anyway, they're always true under the same circumstances, which is more to the point. Anyway, just follow the rules whether you understand them or not to complete your proof is my advice if you don't have the time or the ability to understand. Or if I don't have the ability to explain it, that too. Anyway, material implication rule tells us P horseshoe Q or P arrow Q means the same thing as tilde P wedge Q, which allows us then to get from A arrow B to tilde A or B. Now, Mark's advice, once you've used a premise, usually you won't need to go back to it. Sometimes you do, but usually you don't. Don't cross it out on your homework, but just a quick visual. Probably what we want to do next is look at 2 and 7. Oh, sorry, to fill in my citation. Material implication on line 1. Material implication on line 1 is what we just did. So probably what we're going to do next is look at premise 2 and premise 7. 7 is a conclusion with respect to our initial premises, but now it's going to be a premise for what comes next. It's a sub-conclusion, logic vocab from Unit 1. And we're not likely to look at premise 1 again. So there we go. And after we get number 8 set up, we'll probably not look at 2 again or 7. We'll be able to X those out as well, except don't X them out. I'm just doing a quick visual here so we remember what not to look at. So now let's look at 2 and 7. And it should be fairly simple. This looks to me like a very straightforward modus ponens. Slow down if you need to slow down, but modus ponens tells us for any statements, P and Q, if you have the premise if P then Q and the premise P, you can conclude Q. So tilde A wedge B is a statement. Let's let that be P, let Q be C, or let C be Q, and therefore C by modus ponens on lines 2 and 7. So now we've used premises 1, 2, and subconclusion 7. We probably won't look at them again. The next place to look is a premise we haven't used yet, plus what we just accomplished. And it turns out the same patterns can continue for a bit. Oh, maybe not. Well, we'll see, won't we? Okay, so now we have C. How do we get from C to D is our next goal? Well, actually, we can't go directly. So we're actually not going to look directly at 3. We can't do modus ponens on it yet. That's sloppy. That's skipping a step. That's a rookie mistake. First, do a double negation on line C. So my mistake, we cannot go directly to C. Sorry, we cannot go directly to working with premise 3 and premise 8. First, we've got to make premise 8, or the information in premise 8, match what we need it to match premise 3. We don't have a rule for tilde tilde P, therefore Q. No matter what follows after it. What we have is a rule for if P, then Q, and P, then Q, modus ponens again. But first, we have to make C, or the information in statement 8 here, match what's in this one. Our P in P arrow Q, P therefore Q is going to be tilde tilde C. So we have to get tilde tilde C from C. Don't skip steps. So that's a double negation on line 8. So now, just to visualize, though again, don't write this in your homework. Maybe a check mark off to the side is fine, or something like that. Your teacher probably won't mind. I suppose it's between you and your teacher. We've already used premises 1 and 2 and our subconclusions 7 and 8 here. And now we probably can go directly at last to number 3 and number 9 and get D from them by a simple modus ponens. Modus ponens on lines 3 and 9 will give us D. So now, just to visualize, we've already used these premises and these subconclusions. So what's left that's going to get us to J is these 3 premises and subconclusion D. And now, if you're thinking, how do I get to J from D? What about E? Well, there's one simple rule that will accomplish it. Our only way of getting to J is to do something with premises 5 and 6 here. And our only way to get there is to have H or I or both. We need one of them affirmed, or we need either of them affirmed. That is to say, we need the affirmation of their disjunction, which conveniently is right there in premise 4. So we need to get this somehow from D or E. So basically, what I'm saying is everything except D or E in premise 4 is useless to us at this point. We need to get to J. To get to J, we need to get to this stuff. To get there, we need to get there. To get there, we need to get here. To get here, we need to get here, which is a fancy way, or a very unsophisticated, unfancy way of me saying somehow we've got to get from D to D or E. Well, as it turns out, there's a rule that lets us do that in one step. Do you remember what it was? I believe we called it addition. If a statement is true, then the disjunction it and any other statement is true. If D is true, then it's true that either D or E is true. So addition on line 10 gets us to D or E. And now we're ready to apply D or E to line 4 with a modus ponens. That'll give us H wedge I. So again, I don't recommend doing this on your homework, but I'm going to keep doing it just to visualize, and then I'll undo it in a moment because it's a simple formatting step. Now we're using D or E in 11 to get to H wedge I from premise 4 by modus ponens. So now the rest should be fairly simple. How do we get to J from here? Actually, it's not fairly simple. There's one wrinkle. But the first step should be fairly simple. We've seen it enough times. We've illustrated several times. It's a constructive dilemma. So now let's just remember what we want to look at and strike through any text. So now looking at lines 5, 6, and 12 to 5, 6, and 12 to get to J, we need to apply constructive dilemma to lines 12, 5, and 6, and in that order. That'll give us J or J. What did I say? 12, 5, and 6. Let's check that. 12 gives us H or I. 5 gives us if H then J. 6 gives us if I then J. The conclusion is J or J. And you're thinking J or J, that's the same thing as J, right? Well, you would be right. But what that means is just that you understand the redundancy steps. So we apply redundancy to J wedge J because don't skip steps. I guess we're not using a D when we cite the redundancy rule. All right, don't skip steps. Remember, when you apply the constructive dilemma rule, you've got to have the pattern applied precisely. The pattern is P or Q, if P then R, if Q then S, therefore R or S. Now, in this case, R or S both symbolize J. That's what the pattern is. They can symbolize any statement. Sometimes they can symbolize the same statement. Depends on what statements we have. So P or Q, if P then R, if Q then S, therefore Q or, if P then Q, if P then R, if Q then S, therefore R or S, is the constructive dilemma pattern. We apply it now to these statements, H or I, if H then J, if I then J, and it turns out R or S are both referencing J in this case. So what are we left with? R or S. They both reference J, so J or J is what we get by constructive dilemma form. Don't skip steps. But if you're thinking, I should be able to skip steps because they mean the same thing, you're not understanding proofs properly, but you are understanding a whole lot of the logic properly, just not the strategy. The strategy is prove every dang step using a rule. And we don't have a special constructive dilemma rule for if for either P or Q, if P then R, if Q then R, therefore R. We don't have that rule. We could call it constructive dilemma variant A rule or something. And I don't know, we could cite as CDVA or some such. We could do it, but then we have too many rules to keep track of. It's better to just have the occasional rule for not skipping steps like double negation and redundancy, and everything works out fine. We don't have to memorize any special rules, just apply constructive dilemma. Don't skip steps, know how to get to where you need to go without skipping steps, in this case using the redundancy rule. Okay, that's it. I'm done. Go away. I'm going away. See you next time. Thanks for watching.